Assalamu alaikum. Now we will discuss about the working principle of MOSFET. So here we can see the schematic structure of MOSFET. Here the four terminals: source, gate, drain, and body. But the source and body are interconnected to the ground, so it may be called that the MOSFET has three terminals, that is source, gate, and drain. The source and drain are of N-type material, and the body part is of P-type material. This type of MOSFET is called NMOS. We will discuss the working principle of NMOS here. Um, the source and between the source and drain material, there is an oxide layer above which a metal is situated and above which a gate terminal is connected. That's why this is called oxide layer. Metal oxide semiconductor field effect transistor, that is MOSFET. So how this MOSFET actually works? Um, so when a voltage is applied across drain and source, then what happens? Well, when a voltage is applied between drain and source, then due to the positive voltage of drain terminal, the N-type materials voltage becomes greater than P-type material. Then a depletion region between the N-type and P-type material increases between drain and substrate. That's why if the voltage is increased of drain and source terminal, no current actually flows because the depletion region becomes higher and no electron will flow from source to drain. But when a gate voltage is applied between source and gate, then what happens? Then the positive voltage of gate will attract the negative charges of p-type material. So all the electrons of this substrate or p-type substrate, all the electrons will be attracted through the gate. But because of the oxide layer between this, which works as an insulator, no electron will pass through this layer through the gate. So here all the electrons will accumulate in this place, and thus it will create a channel between source to drain. By this, the electron will pass through the channel from source to drain, and as we know that the flow of electron will create an electricity pass from drain to source. That's how the current flow starts, because of the voltage of gate and source. That's how the channel created, and that's how the electron flows. Now, if the voltage of VDS, that is from drain to source, is increased, then what will happen? The amount of current will increase. Because of this, channel will be increased and the flow of electron will be increased. So the current will also be increased. So with this voltage, the current will be increased. But what will happen if we increase it to a specific limit? Then the depletion region will also be increased between the drain and the body. So because of this depletion region, this channel will be shrinked. So the flow of electron will be limited. So that's how at a specific time, after a specific time, the flow of electron will be limited and it will be fixed to a fixed value. And it will go to a saturation, which is called the saturation region. So for different type of gate voltage, we can call the graph will be like this. For different type of gate voltage, these different curves will occur for current versus VDS. And this region is called saturation. This region is called saturation, and this region is called triode region. And another region of MOSFET is the cutoff region, where if the gate voltage is not applied and no current flows in the MOSFET, that region is called cutoff region. So this is the three type of region or three type of mode of MOSFET, and that's how the MOSFET that's how the current flows in MOSFET. For your better understanding, we can see here how actually the current flows. If the voltage is increased, then the depletion region is also increased, and at a specific time the flow of current will be limited, and then the saturation region is occurs. And that's how the working principle happens in MOSFET. Thank you.